Okay, Walker, so we're at 1.3, solving systems of three linear equations. You can solve systems of three linear equations in three variables by using substitution. First, solve one equation for a variable and then substitute the expression into the other two equations. This reduces the system of three equations in three variables to a system of two equations in two variables, which you can then solve using any method. As a fundraising event, a club sold tickets to a special viewing of a classic movie. The club sold 800 seats in the school's auditorium. The tickets were three different prices: $2.50 for children under 12 years old, $3.50 for youth between 12 and 18 years old, and $5 for adults. The total amount of money taken was $2,937.50, and there were 4 times as many youth tickets as children's tickets sold. So first off, C is children's tickets, T is youth tickets, and I'm going to go ahead and make adults a capital A is the number of adult tickets, okay? So our first equation is C plus T plus A equals 800. And then money. Children's tickets are $2.50 plus youth tickets are $3.50 plus adult tickets are $5. Money goes with money, goes with money, goes with money. So $2,937.50. And then our last equation is that there's 4 times as many youth tickets as children's tickets. So T equals 4C. Now, we can substitute this in for T here and here. And so let's go ahead and do that. So we have 1C plus 4C plus A equals 800, which when you simplify, that's 1 plus 4 is 5C plus A equals 800. Now, let's call this equation 1. Let's call this equation 2. Let's call that equation 3. So this is equation 4. Okay, so now we plug this in. So that's 2.5C plus 3.5 times 4C plus 5 equals 2937.5. So when you combine these, this becomes 16.5C. Oh, almost got, there's an A right there. Plus 5A equals 2. Okay. Now to solve, what we're going to want to do is multiply equation 4 by negative 5. Okay. So we do that. Negative 5 times 5C is negative 25C minus 5A equals negative 4,000. That's equation 4 times negative 5. Okay. Now we're just going to leave equation 5 as so 16.5C plus 5A equals 2937.50, and that's equation 5. Okay, well, this becomes 0. This becomes, let's see, double check, negative 2.5 plus 16.5 is 14, so that's 14C equals negative 4,000 plus 2937.5. Oh, I just caught a mistake. You want to be careful. I forgot to multiply, or actually I multiplied incorrectly. Negative 5 times 5 is 25. So you want to be careful to make mistakes. But again, the mistake I made was negative 5 times 5 is negative 25, not 2.5. I don't know how the decimal came about. And so mistakes happen. You want to be careful and just be checking as you work, just to try to catch any mistakes that could happen. So now we combine this So negative 25 plus 16.5 is negative 8.5. Equals, and then now we need to combine these. Okay, now we're going to divide both sides by negative 8.5. So C equals, that divides becomes 1. That's 125. Okay, so the children's tickets were 125 total. Okay, now we can plug this into this equation. Okay, so T equals 4 times 125, which equals 500. So the youth tickets are 500 youth tickets. Now we know there's a total of 800, so we know that A equals 800 minus 500 minus 125, which equals 175. So there were 175 adult tickets. All right, go ahead and finish up that page. Get the page turned. Good. All right. Now, we're not going to worry about Alice and Emily's work, but we are going to worry about, so we're not worried about Alice and Emily, but we are going to worry about solving the system. Okay. Now, there's not enough space here, so I'm going to turn my page over and use that space. So we're going to do that here. Okay. Let's call this equation 1. Let's call this equation 2. Let's call this equation 3. Now, we're looking to eliminate, and it looks like we can eliminate the y's right here. So we're going to combine 2 and 3. So we have 2x minus 3y plus 2z equals negative 14, and that's equation 2. And 4x plus 3y minus 1z equals 5, and that's equation 3. Now, 2x and 4x is 6x. This becomes 0. 2z minus is plus 1z equals negative 14, and 5 is negative 9. And let's call that equation 4. Now, if we multiply equation 1 by 3, we can combine these and eliminate the y. So let's do that. So then that's 3x plus 3y plus 3z equals negative 6. That's equation 1 multiplied by 3. And then we're going to use equation 2. So that's 2x minus 3y plus 2z equals negative 14. And that's equation 2. Okay, so then we have 5x. This becomes 0 plus 5z equals negative 20. And let's call that equation 5. Okay, now let's try to eliminate, and it looks like probably our best opportunity is here and here. So let's multiply equation 4 by negative 5. Okay, so when we do that, we get negative 30x minus 5z equals 45. And that's equation 4 multiplied by negative 5. And then now we combine it with 5. So that's 5x plus 5z equals negative 20. And that's equation 5. Okay, so this becomes 0. This becomes negative 25x equals 25. So when you divide by negative 25, x equals negative 1. Now, I can plug this back into equation 5 to solve for z. So I have 5 times negative 1 plus 5z equals negative 20. Well, that's negative 5 plus 5z equals negative 20. Add 5 to both sides. 5z equals negative 15. So z equals negative 3. Now, I'm going to come back to the first equation. I have x plus y plus z equals negative 2. I can plug this and this into here and solve for y. So that's negative 1 plus y minus 3 equals negative 2. Negative 1 minus 3 is negative 4, so y minus 4 equals negative 2. Add 4 to both sides, y equals 2. So my solution is negative 1, comma 2, comma negative 3. All right. Go ahead and finish it up, and let's take a look at the next page. All right, we're actually going to ignore that page so we can move on. All right, let's take a look at 1.4, Gaussian elimination. Gaussian elimination is a method for solving linear systems equations named after the mathematician Carl Friedrich Gauss and involves using linear combinations of equations to isolate one variable per equation. The goal of Gaussian elimination is to eliminate all variables except one in each equation. To do this, look for ways you can add or subtract two equations to eliminate one of the variables. You can multiply one or more of the equations by a constant before adding or subtracting. All right, we're gonna ignore this example. Let's move on to the next. We're gonna actually ignore this page, so we're gonna move on. Now, we don't care what Jamie claims. What we do care about is solving. Let's see, move. We care about this right here. We're gonna solve this system, but we don't care about the other. So we're going to come over here. I'm going to turn this to the back page, and let's go ahead and solve this. Okay. I think this is question number 2. So question number 2. Okay. So let's call this equation 1, equation 2, equation 3. Now we're looking for things that eliminate. Okay. But wait, these two equations already have x eliminated, so we can use these equations. So let's multiply equation 2 by a negative 2. So that becomes 8y plus 2z equals 14, and that's equation 2 multiplied by negative 2. And then we're just going to use equation 3, so negative 8y minus 5z equals negative 11, and that's equation 3. So now this becomes 0. 2z minus 5z is negative 3z. 14 minus 11 is 3. So z equals negative 1. Okay. Now I can plug that back into either of these equations to solve for y. I'm just going to plug it into equation 2. So negative 4y minus a negative 1 equals negative 7. So that becomes negative 4y plus 1 equals negative 7. Subtract 1 from both sides. You get negative 4y equals negative 8. So y equals 2. Now, I can plug these back into any of the equations to solve for. I'm just going to plug in the first one. So x plus 3y plus 2z equals 5. I'm going to plug in this and this into here to solve for x. So x plus 3 times 2 plus 2 times negative 1 equals 5. So 3 times 2 minus 2 is 4. So this becomes x plus 4 equals 5. Subtract 4 from both sides, x equals 1. So your solution is 1, 2, negative 1. All right, go ahead and finish that up. All right, let's take a look at the next page. All right. Again, we don't care about Ethan, Jackson, and Olivia. All we care about is we want to solve the system. Okay, so let's go ahead and do that. And again, I'm going to work it on the back page. You have to use a separate sheet of paper. Call this equation 1, call this equation 2, call this equation 3. Now, you see here that if I combine 1 and 2, the y's will eliminate. Let's go ahead and do that. So negative 2x plus y plus 2z equals negative 3. That's equation 1. Negative 3x minus y plus 2z equals negative 11. That's equation 2. So this becomes 0. You get negative 5x plus 4z equals negative 14. Let's call that equation 4. Now we can combine equations 2 and 3. So that's negative 3x minus y plus 2z equals negative 11. That's equation 2. 2x plus y minus z equals 8. That's equation 3. Okay. Negative 3x, and here's this, negative 1x. That becomes 0. 2z minus z is plus 1z equals negative 3. And that's going to be equation 5. Okay. So now we need to look at equation 4 and 5 to what we can eliminate. So it looks like here I have a negative 5. If I make this a positive 5, okay, then these will eliminate. So I'm going to multiply equation 5 by negative 5. Okay, so we're going to keep that equation. So negative 5x plus 4z equals negative 14. That's equation 4. But now we're going to multiply by negative 5. That's 5x minus 5z equals a positive 15. And that's equation 5 multiplied by negative 5. Okay, this becomes 0. This becomes negative 1z equals positive 1. So z equals negative 1. Now, I can plug this equation into here to solve for x. So we have negative 1x plus 1 times negative 1 equals negative 3. Well, here I can add 1 to both sides. So you get negative 1x. This becomes 0 equals negative 2. So x equals 2. Now, we can come back to any of the equations. I'm just going to use, we're looking for y. So I'm going to use the third equation. So 2x plus y minus z equals 8. I'm going to plug these values in to solve for y. So 2 times 2 plus y minus negative 1 equals 8. So that's 4 plus y plus 1 equals 8. So y plus 5 equals 8. So y equals 3. So the solution to your system is 2, 3, negative 1. Okay, go ahead and finish it up. All right. Let's take a look at the next page. Now, We're not going to worry about this, but we are going to worry about number 5. Okay. Colleen has 12 coins in her pocket. The mix of quarters, nickels, and dimes add up to $2. She has 3 times as many quarters as nickels. Okay, so we're going to write our equation. Okay. So first off, we have quarters, nickels, and dimes. So quarters plus nickels plus dimes equals 12. There's 12 coins. Now we talk about money. Okay. Now, quarters 25 cents, so that's 0.25 Q plus 0.10 N plus, nickels are 5 cents and dimes are 10 cents. Equals, and now money goes with money goes with money, says the $2. So equals 2. And then it says she has 3 times as many quarters as nickels. So quarters equals 3 times nickels. Now, here we can use decimals, but if we convert everything to pennies, then we can rewrite this as, well, let's just rewrite this. I'm not going to do anything to this yet. But now we can rewrite this as pennies. So that's 25 Q plus 5N plus 10D equals 200. And then Q equals 3N. Okay, now we're going to plug this in for the Q's. Okay, so then that's 3N plus N plus D equals 12. Okay, and that becomes 4N plus D equals 12. Plug this into here, so that's 25 times 3N plus 5N plus 10D equals 200. Well, that's 75 plus 5 is 80, so that's 80N plus 10D equals 200. Okay, this was equation 1, this was equation 2, this was equation 3. Now we have equation 4 and 5. Now, the best thing to probably do is multiply 4 by negative 10. Okay, so now we have negative 40N minus 10D equals negative 120, and that's equation 4 multiplied by negative 10. Now we're just going to use equation 5. So 80N plus 10D equals 200. That's equation 5. Okay, combines, that's 40N. This becomes 0 equals 80. So N equals 2. Okay. Now we know that quarters equals 3 times N. So that's Q equals 3 times 2, which is 6. So quarters equals 6. Now we know there's 12 coins, so the number of dimes equals 12 minus 6 minus 2, which equals 4. So dimes equals 4. All right, go ahead and finish that up. Let's take a look at the next page. All right. The next page is your assignment. You're going to do the in book and Edulastic. All right, go ahead and start working on that and have a wonderful Wildcat day.